So in 15 we have y equals 2x plus the square root of x. So y prime. There is also another notation, the derivative of y with respect to x. Same thing. There is also another notation, same thing. If this is f of x, we are determining f prime, or y prime, or dy by dx. Leibniz notation. Okay, so can anyone differentiate 2x plus the square root of x? So we can write the answer. 2x prime. Maybe we should have added to the list. What do you think? Just simply plain x prime. What will that equal to?
That's 2.
What is the slope of x? If we write y equals x, what will be the slope? That's the answer. 1.
Wait, why is it 1 and not 2?
Okay, so it's x to the first power, right? Prime. We bring down the 1 and multiply by x to 1 minus 1.
Okay.
But x to 0 is 1. As long as we're not talking about 0 raised to 0. Or, because it's a linear function, you are really asked to find the slope. The slope of x is 1. Now, if we're asked to find the slope of 2x, yes, that will be 2. If y equals 2x, then the slope will be 2. But if it's just plain x, the slope is 1. Because this is 1 times 1 is 1. Good. So can anyone, because I wrote already too much around here, let me write it again. So we have 2x plus the square root of x. I'm on page 4. So y equals 2x plus the square root of x. So how much is y prime, or dy over dx? Ah, you were saying 2 for this. Oh, I was talking about x prime. But yes, here you're right. It's 2. Yes, of course.
Yeah.
2. Okay, yeah, I'm sorry. Okay, so can anyone differentiate the square root of x? We just wrote it as a formula, and we will have to forever remember it. So what is the square root of x prime? Please. Can anyone give us the square root of x prime? Anyone, please?
X to the negative 1/2.
So how much is the square root of x prime? Give it a shot, please. Please try. Tell me what you think.
Is that x to the negative 3 over 2 over 2?
So what should I write?
That would be 1/2 root x.
That's it? Perfect. Awesome. Thank you so much. Let's continue. Let's choose other problems or we move on. Anything you would like to work on? 23 is a good one. Let's work on 23. Please choose if you want to. So we have f of x equals 3x squared plus x to the third divided by x. Okay. I want to refresh your memory on some algebra. If I have a plus b plus c, and of course I can have minus, divided by d, since the numerator has 3 terms, I can split this into 3 fractions. As long as the denominator is exactly 1 term. I won't do this if it's more than 1 term. If I have plus e, I cannot do this because I won't be able to simplify. So please remember this little trick. It's not a trick. We go back and forth. From here I can write this, and from here I can write this. So therefore, can anyone tell us how to present this fraction? Because it has only 1 term in the denominator. So what should I do? How do I split this fraction?
That's 6x over x.
So it's 3x squared over x, yes, plus
X cubed over x.
x cubed over x. Then we will simplify. Can anyone simplify 3x squared over x and tell us what to write?
3x.
Very good. Can anyone simplify x to the third by x and tell us what to write?
X squared.
That's it, x squared. This is what I want to differentiate. I don't want to differentiate this if I can make it easier. So always keep in mind factor, if it helps, and simplify. These are key words. Good. So then the function is 3x plus x squared, and I can find its derivative. Can anyone differentiate 3x plus x squared? And I'll write it here.
Three plus 2x.
Plus 2x.
Excellent. This is it. See, always, if I can make my life easier, why would I even look at this? But the key is 1 term. Don't change anything. I'm going to erase it. But if I have this, I can't do anything. Because even if I write 3x squared over x plus 1 and x cubed over x plus 1, I won't be able to simplify. So that will not work. But as long as the denominator is just 1 term, always think of this little trick. It's not a trick, it's just simple algebra. Good. Let's continue. Okay. Let's see if we want to work on anything else. Let me know if you want to choose. Or just choose. Anything else catches your eye. Again, this is the same thing. We're asked to find dy over dx or dy over dt. Let me explain a little bit why this notation is so important. You can say, I don't need 3 notations for the same thing. Why do I need 3 notations for the same thing? This is very specific because it says y is a function of x. This one doesn't say that. If I don't see the function, I don't know what is the independent variable. If I tell you f prime, you don't know if you don't have the function. If I say find f prime of x, it's clear, which means f is a function of x. But this is also clear. It means you differentiate y with respect to x. There is only one variable, and that variable is x. We're not discussing here, we're not going to look at functions with more than one variable. But the notation for more than one variable is this. Which means y is a function of x and some other variable, at least one more, like t, z, whatever. But the normal D says y is a function of one variable, and that variable is x, and we want you to differentiate y with respect to x. This is called the partial derivative. But we are not discussing partial derivatives in this class. I just want you to understand the difference. This one specifically says it's one variable, it's a regular D. This one is not the regular D, and it means that we are differentiating with respect to x, but y has other variables in it, at least one more. Okay. So let's go back. So if we're asked to find dy over dx, it means that y is a function of x, not of t. When we're asked to find, and t is just a number, not given to us, but just a number. If we're asked to find dy over dt, it means that y is a function of t alone, and x is just a number. It should be treated as a number, although we don't have it. Any questions on this? Okay, so let's find the equation, because this is very important. We always find equations of tangents and so on and so forth. So let's choose a problem from 37 through 40. Anything. Any problem you want to work on. So we can find the equation of the tangent line to the graph of a function at a particular given point. Okay, I'm on page 5. Yes, I'm ready. Which one? Which one? Any preference? Well, I will look at 39 then, if you have no preference. So 39 is y equals x plus 2 over x, and the point is 2 comma 3. I always like to make sure, is the point 2 comma 3? Let's see. 2 over 2 is 1, 1 plus 2 is 3, correct. So they're asking us to find the equation of the tangent line, y minus 3 equals the slope x minus 2. This is the x1, and this is the y1. But the question is, how do I find the slope? How do we find the slope? Can anyone give us an idea on how to find the slope? Anyone, please. What does the slope represent? How do we determine this? So if this function, let's say, has this graph, it doesn't, and this is the point 2 comma 3, we're asked to find the equation of this tangent at this point 2 comma 3. So y equals, how do we find that? I have the point, but I don't have the slope. How do I find the slope of the tangent line? What is the definition of that slope? Please talk to me, please, and just tell me anything that comes to your mind concerning this. Please, anyone? I would like us to have a conversation. Anyone remembers how to determine the slope of this line? How do I get the slope of the tangent line?
By finding the derivative.
Yes, and plugging in. So see, now this is not a convenient notation. If I write dy over dx, then I have to write in this way, plug in x equals 2. This is the slope. Thank you so much. Now, it would have been much easier to write f prime of 2, right? This would have been easier. You can denote this at any point in time if you'd like by f of x. No one stops you. So you either determine this as being the slope, or you determine if you want to use dy over dx. Now, y prime, we don't really write this, but even y prime works with this notation. Awesome. So then, can anyone give us y prime, or dy over dx, or f prime of x? Can anyone identify f prime of x here? And I'll write it down. Please try.
Would it be the limit as h approaches
No.
0?
Differentiation rules. We're done with the limit. Done with the limit. But you're right. It's the limit of the difference quotient, but we are done with the limit. We want to differentiate x. What do we get?
It's a constant, so that would be 0.
Careful. X is not a constant. When we differentiate 3, we get 0. When we differentiate x, we get
Is it 1?
exactly.
X to the 0, that's 1. So
X prime is 1. Very good. Now, plus 2 over x. Remember, 2 over x can be rewritten as 2 times 1 over x. So plus 2. Anyone remembers what is the derivative of 1 over x? This is a rule. We have to carve it in stone. So we don't ever have to think about it. The derivative of 1 over x. Derivative of 1 over x.
Is that negative 1 over x squared?
That's it. Indeed. So it's negative 1 over x squared. So then f prime of x is 1 minus 2 over x squared. But now we have to plug in 2. So f prime of 2. 1 minus 2, 2 squared is 4. 1 minus 1/2 is 1/2. Now I can plug it in. Y minus 3 equals 1/2 times x minus 2. Distribute 1/2 x. 1/2 times negative 2 is negative 1. But I have to add 3. So y equals 1/2 plus x, of course, 1/2 x plus 2. This is the equation of the tangent line to the graph of the given function at the point 2, 3. And now I know you're asking, because we've done something like this several times now, who cares? Okay, fine. You're giving me a function. You're giving me a point. Who cares about this? Why is this so important? Why am I struggling to determine the equation of the tangent line all the time?